Hello everyone, welcome to EEEE Lecture number 13. Today we are going to continue on the module number 2, that is AC circuit. So this is the second lecture for AC circuits. So last time we have started with defining some AC terminology, and we have discussed about generation of AC voltage, alternating voltage, and also we have written the standard forms of AC voltage and AC current. All right, so let's continue with the numerical. So numerical says an AC current of frequency 60 Hertz has a maximum value of 12 amperes. So frequency is around 60 Hertz and the maximum value of AC current is 12 ampere. So that is IM. Write down the equation of the instantaneous current. Next, find the value of the current after 1 by 360 seconds and find the time taken to reach 9.6 amperes for the first time. So here we have to write for the first time. All right, so let's start solving this numerical. So I'll use a blue color. So first of all, we have to write it in the form of instantaneous current equation. So standard form of current is I is equal to Im sine omega t. All right, this we can write it as Im sine 2 pi f t. All right. Now for us the frequency is given and Im is given. So for us Im is around 12 amperes and frequency is given around 60 Hertz. So this will be I is equal to 12 sine 2 pi into 60 t. Alright, so it will be I is equal to 12 sine, if I multiply it, I will get it as 377 t. Alright, so this is my equation for the instantaneous current. So let me add, this is the instantaneous current equation. Instantaneous current equation. Okay, so let's go to the second part. So the first part is completed. Second part is we need to find the value of the current after 1 upon 368 second. So we write it, you'll find it value of current after 1 by 368 second. So that means we need to find the instantaneous value of I when t is equal to 1 upon 360. All right. So we rewrite the equation, instantaneous current equation. I is equal to 12 sine. Here we have 377, but this is in radians and multiplied by t. T is 1 upon 360. So since it is in radians, we have to convert radians to degrees. So we have to multiply by 180 by pi. Now this becomes in degrees. Okay. So it will be I 12 sine. Here if you calculate this, you will be getting around 60 degrees. So 12 sine of 60 degrees will give you the answer as 10.39 amperes. So this is the value of the current after 1 by 368 second. Now let us find the next one. Find the time taken to reach 9.6 amperes for the first time. So we'll now calculate third part, time taken to reach for the current to reach 9.6 amperes for the first time. All right, so here we'll write I is equal to 12 sine 377t. This is what we got, right? And they have asked us to find the time. So when current has reached 9.6 amperes, so I is equal to 9.6, 12 sine 377t. So here we need to find the time. All right, so I'll write it as sine 377t is equal to 12. Let me write it as 9.6 divided by 12. That comes out to be 0.8. All right. So inside this it is in radians, so we'll write it as that is sine of 377 t into 180 by pi. So now it becomes in degrees is equal to 0.8. So if I take sine inverse on both the sides, I'll get 377t into 180 by pi is equal to sine inverse of zero point 0.8. So t will be equal to this sine inverse of 0.8 is coming out to be 53.13. This will be multiplied by pi divided by 377 into 180. So if you calculate this, t will come out to be 2.46 into 10 raised to minus 3 seconds. We can write this in terms of milliseconds. So t is equal to 2.46 millisecond. So this is the time taken by the current to reach 9.6 amperes for the first time. All right. So yeah, we have completed numerical number 1. Now let's go to another numerical. So an AC current takes 3.375 millisecond to reach 15 amperes for the first time after becoming instantaneously zero. Frequency is given as 40 hertz. We need to find the maximum value of AC current. So let's start. So let us write the standard form. I is equal to Im sine omega t. So Im sine 2 pi f t. All right. So here the value of Im is given. So we can write over here the value of I is around 15 amperes. So this will be 15 amperes is equal to Im value we need to find out. So Im is what is we need to find out. Im is equal to how much? Then sine of 2 pi frequency is given as 40 hertz. So 2 pi into 40 into t. All right. So from here we need to calculate Im. So here we'll have 50. 15 is equal to Im sine of, this is in the radians, so we need to convert it into degrees. So it will be 2 pi into 40. T is also given. T is 3.375 millisecond. So it will be 3.375 into 10 raised to minus 3. And we need to convert it into degrees, right? So it will be 180 by pi. Radians to degrees conversion. So if we calculate this on the right hand side, it will be sine of 48.6 degrees. All right. So if we calculate Im from here, Im will be 2 amperes. So that's the maximum value of AC current which we have. All right. Okay. So over here, the given data was I was 15 amperes. We need to find Im and frequency was given. So we need to find the maximum value of the AC current, and that was Im, and it is around 2 amperes. Now let's go to the next numerical. Numerical number 3 for today. An AC voltage is given by V equal to 10 sine 972t. So let us write the standard form first. V is equal to Vm sine omega t. And what have we given? V is equal to 10 sine 942t. So if you compare, you will get Vm as 10 volt and omega as 942 radians per second. So this is the information we have given. Now what we need to calculate, listen carefully. We need to calculate the time taken from t equal to 0 for the voltage to reach a value of plus 6 volts for the first and the second time. Alright, now let me explain it to you diagrammatically. So let me draw an AC waveform over here. So this is my AC waveform. Alright, x-axis is omega t. This is V. This maximum value is plus 10 because here it is Vm is 10. This will be minus 10 volt. Alright. Now this is 0 and the maximum is 10. So we have to find the time taken for t equal to 0 for the voltage to reach a value of plus 6 volt. So this is 0. This might be 5. So over here it will reach plus 6 volt. So we need to calculate this time t1. Let's say this time is t1. This is pi, 2 pi, 3 pi. And we need to calculate, this is the first time. This is the first time when the voltage reaches 6 volt. and we need to find for the first and the second time. Now if you consider the first and the second time, it will be for one period, so we cannot say the second time is over here. The second time it will be over here again. So we need to find out, let me rewrite it over here. This will be 2 pi, this is separate, and this time will be t2. So we need to find t2, and t2, if you see carefully, from year to year we have t, capital T, period. Okay, so for this time also can be written as t plus t1. So once we know the value of t1, once we know the value of capital T, we can easily find the value of, this is the voltage to reach a value of plus 6 for the second time. So this is the second time, this one. So there are two things. First we need to calculate the time t1, and we need to calculate the time t plus t1, capital T plus t1. Got it? All right, so let's do that. I hope you have understood. Calculate the time taken from t equal to 0 for the voltage to reach a value of plus 6 volts for the first and the second time. So for the first time it is t1, and for the second time it is t, capital T plus t1. So let's continue with the solution. All right, so we have calculated and we got the value of Vm and omega. Now V is actually given as, that is, V is around 6 volt, let's say, for the first time, and it is given as 10 sine, and we need to calculate T1. So this will be 942 T1. Now this value is in radians, we need to convert it into degrees. So 6 equal to 10 sine of 942 T1 into 180 by pi. Alright, so here if I take this on this side, it will be 0.6 equal to sine of um, 942 T1 into 180 by pi. So if I take sine inverse now, sine inverse of zero point 0.6 will be 942 T1 into 180 by pi. So from here we can easily calculate T1. So T1 will be, sine inverse of 0.6 will be 36.87 into pi divided by 942 into 180. So this, if we calculate, it will come out to be 0.683 into 10 raised to minus 3 seconds. Alright, so that's the time taken for the voltage to reach plus 6 volts for the very first time. So we have got the value of T1 as 0.683. Okay, so let me write over here, T1 is equal to 0.683 millisecond, and this is the time taken by AC voltage to reach plus 6 volt for first time. All right, now we know that the time taken for the value of AC voltage to reach for the second time is T plus T1. So let us write it down. For the second case, time taken, let me use black color, by AC voltage to reach plus 6 volt for second time is T plus T1. So we need to calculate capital T. How we can calculate capital T? Omega. Omega is given as 942. So omega is 2 pi f, which is 942. So from here we can calculate f, which is 942 upon 2 pi. So your T will be 1 upon f. That will be 2 pi upon 942. That will come out to be 6.67 millisecond. So that's the value of capital T. Now we can easily calculate the time taken by the AC voltage to reach plus 6 volt for the second time will be T plus T1. That will be 6.67 millisecond plus, how much is T1? T1 is 0.683. 0.683 millisecond, and this will come out to be 7 point, sorry, this will come out to be 7.35 millisecond. All right, so that's the value of t plus t1, or time taken for the AC voltage to reach plus 6 volt for the second time. And this concludes our numerical. All right, I hope it is clear. Now we move on and continue with some more AC terminology. So let's continue with AC terminology. We have discussed few terms, but we will continue now AC terminology and we'll discuss few more terms now. So first is peak value. So how do you define peak value? So let's say this is my AC waveform. Okay, this is omega t. Let me draw one more cycle. Now what's the peak value? Over here, the positive peak value is, if this is Vm and this is minus Vm, peak value is also called as maximum value. And for this case, it is Vm. Vm, or in a negative half cycle, it is also Vm. So it is represented by, let me write it clearly. Peak value or a maximum value is, it is represented by Vm if it is a voltage and Im if it is a current. Okay, so it's Vm or Im. And how do you define it? It is the maximum value attained by an AC quantity. Now AC quantity can be a voltage or a current. The maximum value attained by an AC quantity is uh, peak value or maximum value. Now there is peak to peak value also. So that is also will write peak to peak value. Here it is 2 Vm. How do we write it? This is peak to peak value. So it is Vm minus or minus Vm, which is nothing but 2 Vm. I hope it is clear. The peak to peak value is twice Vm. Now let us define the another term over here for AC terminology as average time. Let me use a different color. Average value. Average value of AC quantity. Now its definition it as follows. It is defined as the arithmetic mean of all the instantaneous values over one complete cycle. Okay, it is defined as the arithmetic mean of all the instantaneous value of the AC quantity over one complete cycle. All right, so let's take an example and explain. So example, find the average value of the following waveforms. So let's draw the waveforms over here in the next page. So these are my this is my waveform. This is T. Let me use a red color to represent it. So here it is 1. Then we have 1, 2, 3, 4, 5. So these are the waveforms. Okay, let me mark this as this is 1, 2, 3, 4, 5, 6, 7 and 8, and this is 0. Okay, this maximum value over here, over here, over here and over here, this is around 40, 60, 80 and 100. So we need to find the average value of this waveform. So now what is the average value of this waveform? At all the instant of time, that is at 1, at t equal to 1, 2, 3, 4, write the value of voltages and divide by the total number. So what are the number of instances? 1, 2, 3, 4, 5, 6, 7, 8. So we'll divide it by 8, and all the values over here, the instantaneous values at t equal to 1 is 40. Here the value is 0. So first we'll write 0, 0 plus 40 plus 60 plus 80 plus 100, again plus 80 plus 60 plus 40. Alright. So let's do it. 0 plus 40 plus 60 plus 80 plus 100, and again we'll have over here uh, 80 plus 60 plus 40 and divided by 8, because there are 8 instances. And this, if we calculate, it comes out to be 57.5 volt. So the average value is 57.5 volt. All right, so this is how we calculate the average value, and that's the end of this lecture. We'll continue this. We'll solve some more numericals on the AC circuits in the next class. So that's all for today. Thank you all for joining.